Okay, this is Test 3 Review Part 3. This is the dynamic system between killer whales and shore fish. And here we have our model that tells us the number of whales in the future will be based on the current number of whales. And without shore fish, they're going to lose about 30% of their population. So 70% of the whales would remain without the shore fish for food. But if there is shore fish, it will add to the whale population by 10% of the number of shore fish, or for every 1,000 shore fish. 10% for every 1,000 shore fish. And so that gives us this matrix 0.7 and 0.1 for the whales and shore fish on the whale row. And then shore fish are being preyed upon by whales, so their population is going down as the whale population. And of course they're going up 1.3%. It's increasing based on the number of shore fish there are. That's their basic growth rate without being preyed upon by the whale. So that's 1.3. Now, of course, the idea is if you take any particular whale population at some point in time compared to its salmon population in thousands, you're going to get next season's or next year's whale population and next season's salmon population in thousands. So it says to graph the eigenspaces and state what ratios are required for the two populations to survive if this model is long-lasting. So let's first find the eigenvalues, which you can find pretty easily by setting up this matrix and taking the determinant of it and setting it equal to 0. With a little bit of calculating, that turns out to be, I'm just going to skip that part, that goes to lambda squared minus 2 lambda plus 0.96 will equal 0. That's going to be the characteristic polynomial. And that polynomial will give us our eigenvalues. If we use the Pythagorean theorem, we'll get 2 plus or minus